My name is Sid, and this is Tom. And this for the next 1 hour, we plan to talk about hacking XPath 2.0. So just to set the agenda here, we're going to talk about what is XPath, the XPath injection itself. It's nothing new. I mean, there are a handful of papers available on the internet on XPath injection. We will talk about what is already known, what is the new stuff which we've brought on with XPath 2.0. We will be releasing a tool on XPath exploitation, and we will talk about some features. We'll talk about advanced exploitation, and then the boring bit, fixing XPath injection. We'll just keep it simple. Nobody really cares about fixing. Anyways, so who are we? My name is Sid. Well, actually, it's Sumit Siddharth, but it's really complicated. In the UK, I've never seen it spelled correctly. I turned up for the elections, and the person said, actually, you're not the right person. So if you do a pattern match, you will find like 90% accuracy, and surely that's good enough. But anyways, I can't vote in the UK because they can't spell my name right. So I work for 7Safe. I'm the head of pen testing, and we have a team of people who do all sorts of IT security services. I specialize in application and database security. And there's also the SQL injection book, the second edition, which is about to come out, which hopefully a lot of you will like. This is Tom.
My bio is not as impressive as Sid's. I'm a student. I was a summer intern at 7Safe, and this is my project, which has turned into this. I study at University of Hull, and I study computer science and software engineering. And I like to drink, code, and sleep.
Okay, not at the same time.
Not at the same time.
Yeah, okay. So this XPath injection project basically was started as Tom's summer internship at 7Safe. And obviously, Tom did a lot of good work, and we realized that it needs a lot more looking into. So it extended beyond the summer internship project, and we found some neat vulnerabilities, and hence we are here. So if something you don't like, blame Tom. Blame Tom. Okay, so we'll get started. What is XPath? So XPath is a query language. An easy way to understand, those of you who are not familiar with XPath, an easy way to understand it is if you compare it with SQL. So like you have structured query language, SQL, for databases, and you can query a database with SQL and retrieve documents. XPath is the SQL equivalent for XML. With XPath, you write queries and you query an XML database, which is essentially an XML flat file. And you can retrieve various elements of an XML file using XPath. There are two versions of XPath, 1.0, which was released in November 1999, and the XPath 2.0, which is the latest addition to the XPath query language. This was released in 2010. It's a fairly new version, and we haven't seen too many implementations of XPath 2.0. But we hope as time goes by, people will use XPath 2.0, and people will write vulnerable code with XPath 2.0, and they can use our tools to exploit it, and we'll get a little bit more popular. Anyways. So before we get started with XPath, I'll just set the scene. Those of you who are not familiar with the XML nomenclature, this is a little bit of a housekeeping. This is how a typical XML file will look like. We'll go through different elements and what are they called. So every XML file will have something called as a root node. In this example, employees is the root node. Then we will have a node. So for example, the node employee is a child node of the node employees. Similarly, the node password is a child of employee, and it has a name. So everything has a name value pair. So employee happens to be the node name in this example, and another example, the username happens to be a node name, and the value jbravo happens to be the node value. Similarly, you can have comments within each node, and these comments can be placed at different locations. So in this case, the comment employees appears after the root node. So that is the location of the comment. And the value of the comment is obviously between those comment characters, which is employees. Similarly, a node can have attribute. It can have an attribute name, and an attribute name will have an attribute value. So in this case, the ID happens to be the attribute name, and the value 2 happens to be the attribute value. So why use XPath? You want to talk about XPath?
Sure. XPath allows you to write quite complex queries when querying an XML database. XML isn't the easiest thing to work with when you're programming. And you can use it to query basically anything you want. So you can do unions and joins on node sets. You can query children, other nodes. You can even reference external documents when using XPath 2.0. You can, on the next slide, we'll show you some
Okay, and obviously it comes with a lot of default functions. For example, the XPath one has functions like date, string, number manipulation, things like that. So just to set the scene here, for example, if you remember the XML which we showed you, if we wanted to query that XML with certain criteria, this particular query here, this will query the XML document for the username jbravo, and it will return all the elements for that node which matches username is equal to jbravo. Similarly, the second query here is where the input goes into the attribute value. So this will return the second username from our entire XML document. So hopefully this gives you a little overview of how the XPath queries are written and how, when they get executed, how it is manipulated in context of an XML database. Some more examples. So over here we've used the string length function, and we've given the node name, which is the first, which has a value first name. So this will return all the employees with long first name. I think 10 characters is a pretty long first name in Britain, but I think it's a little bit racist, I think. Anyways, similarly, you can have a position function, and you can return, so this particular function will return the first 5 employees within the XML document. Other stuff which you can do, you can call the average function, and you can pretty much like write an XPath expression within the average function. And this will give you obviously the average age of all the employees. Things like that. There are functions like count, maximum, minimum, sum, which you can use. So XPath injection, what is it? It's where the unvalidated user's input is used in XPath queries. The end result is just like a SQL injection. In fact, a very good way to understand XPath injection is to compare it with SQL injection. And I guess most people in this room will be familiar with SQL injection. So it is pretty much like SQL injection, except when you in a SQL injection, you have the queries going onto a SQL database. In this, the queries are the XPath queries, which run against an XML document, or an XML database rather. So if you find an XPath injection, you can do a number of things. You can do an authentication bypass. You can do a business logic bypass, or you can extract arbitrary XML documents, which you will see in a few minutes. So we will start by a very simple example, and this is something, it's like an XPath injection 101. Say, for example, your username, your XML document contains usernames and passwords, and your input is used in the XPath queries for authentication purposes. So the query which will be executed will have username is equal to jbravo and password is equal to pass123. Now, if the input field going to the username is not sanitized, and you inject username jbravo, come out of the string definition by inserting a single quote, and then try to put an OR condition, which is always true, so OR1 equal to 1, and password is equal to anything, then the pseudocode which will be executed would be username is equal to jbravo, the OR condition, which is 1 equal to 1, is always true, and the password condition, or you obviously don't know the password for jbravo, would be false. So this will eventually evaluate to true, and you will be able to log in. We will quickly show you a small demo for this. I mean, this is really 101 stuff. So this is the XML document from the backend system. As you can see, there are some credentials stored in clear text, and this is the XPath query which is run on the backend system. So if you type username admin and password, you can authenticate as Tom. And now if you type Tom's credentials, you can authenticate as Tom. And you can see he's not an admin user. Now if you type admin or 1 equal to 1, which is the Boolean logic you are injecting, and you don't know the password, so you type anything in the input box, you will still be able to log in as admin because of the OR criteria which you have injected, which always returns true. So there was a simple example. Now I wanted to talk a little variant of this, because a lot of people write their own web application security assessment tool, or they run a lot of automated tools, and there's a small, we actually came across a real life example which was vulnerable to XPath injection, and this automated tool didn't pick it up, and we thought it would be good to mention it. So typically, the passwords which are stored in an XML database are stored in an encrypted format, and it's a good practice to store it in an encrypted format, typically MD5 hash or something like that. So when your input is going to into the password field, it will be MD5'd or hashed in some way or another, and the hashes will be compared. So the password field is less likely to be vulnerable than the username field. So if we consider an example in which the password field is not vulnerable because it's MD5 hashed or whatever reason, and the username is the only vulnerable field, and let's work on a scenario where you don't know a valid username. In the previous example, we knew the username was jbravo. Let's assume that we don't know a username. So if we consider this scenario and we try to inject non-existing or some other username which we don't know of, and then the OR criteria, OR1 equal to 1, then the resulting query which will be formed will be username is equal to non-existing, or R1 equal to 1 criteria, which is true criteria, and the password field, which will evaluate to false, because obviously we don't know the valid password. We don't even know the username, so forget about the password. Now the way the XPath expressions are evaluated, AND has precedence over OR. So the way this expression will be evaluated is the true and false criteria will be evaluated first. Now because it's an AND scenario and the right-hand side of AND is false, this will evaluate to false. So this will leave us with a query, username is equal to non-existent or false, which is basically false or false, which will fail. So it's the injecting OR1 equal to 1 is not quite straightforward. However, with a small trick, like if you inject 2 OR criterias, you will still be able to bypass authentication, because this will now evaluate to username is equal to non-existing or true and false. And true and false will evaluate to false, but our second OR criteria which we've injected will evaluate to true. So this will result in a successful authentication bypass. So if you are writing something like an automated tool, you might want to give it some more strings, or if you have a first string which you use, you might want to inject a lot more OR criterias. We can quickly run through this demo. It won't take long. So you want to talk about this?
Yeah, so this is the same as the last one, but the passwords are hashed. So if you log in successfully, and you've got successful authentication, it hashes the password and they're the same. If you inject anything or test, it will fail because the user doesn't exist. If you do 2 OR criterias and anything, it will authenticate as the first user, because that will always authenticate to true, and so it will return the first user. And as you can see, the query there, it's the same as one on the slide.
Okay, that was pretty straightforward. Okay, moving on. So now we'll talk about blind XPath injection. Again, a very simple way to understand blind XPath injection is it is exactly the same as a blind SQL injection. So just like in blind SQL injection, you will not directly get the output of the query, but you can inject the Boolean logic, and depending on what page you see, you will be able to manipulate whether your Boolean logic returned true or false, and hence you will be able to construct the output of an arbitrary SQL query. Similarly over here. So assuming you knew the username of username jbravo and the password mypass, then if you inject jbravo and 1 equal to 1, then you will see a true page, which will be your authentication page. And if you inject jbravo and 1 equal to 2 with your password, then you will not be able to authenticate because you've injected an AND criteria which evaluates to false. So now instead of injecting AND 1 equal to 1 or AND 1 equal to 2, we can inject an AND clause with a particular XPath query, and depending on whether we are able to successfully authenticate or not, we will be able to manipulate whether that XPath query which we injected returned true or false. So for example, if you look at a simple book search page, you search for something like an iPhone user's guide and it returns book found. This happens to be vulnerable to XPath injection. So if you searched for guide single quote and 1 equal to 1, then the query which is run again returns true, and you will still get your string book found. However, if you inject iPhone and 1 equal to 2, this will evaluate to false, and you will not get anything returned from the backend database. So how do we go about exploiting it or automating it? Like I said, it's very similar to SQL injection. The only difference is that it is actually a lot, lot easier to exploit. So in case of SQL injection, you will have a database, you will have a connection string. The user specified in the connection string will only have access to that database. You can fine tune and put a lot more access controls on that particular user. So he's only able to query a particular table, and he will not be able to query anything outside that table. So when you find a SQL injection, you will be limited to what data you can extract, and you can only extract the data which this database user has access to. However, in case of XML, there is no concept of permissions or user. So if you find an XPath injection, you can almost always, I mean, it's hard to imagine a criteria where you cannot dump out the entire XML database from the backend XML. Before we go about showing you how to exploit it and how to automate it, let's just look at a few functions. You want to talk about this?
Yeah. So these are the functions you can use to iterate over the entire XML document. You can count a node reference. So if you were to give it the root node, it would count all of the children of the root node. And the same if you were to give the root node to the name function, it would return the name. The string length function returns a string, the length of a string. So you can use that in combination with the name to give you the length of the search space you need to find. And in combination with the substring function, you can use it to extract one character at a time from a string, and then you can brute force it over a search space. And if it returns true, then the character matches.
Okay, so just to give you some example, if we consider this XML which we are trying to retrieve, then running the function name on the root node. So within the name function, we've given the location where we want the name function to execute. So in this case, it executes on the root node, and it returns the text employees, which is the root node name. Similarly, if we do a count on the child nodes of the first node, so the employees has a child called employee, which has 6 childs. So by running the count function, we can then obtain how many childs that particular node has got. Other things you might be interested in is this is again the name of the node from a different location. I don't know why we decided to put it here. Anyways. Similarly, attribute name and value by calling the @, which is the keyword. It's not really a function, it's a keyword. Yeah, okay. By calling that, you can extract the attribute name. Similarly, by calling the substring function, you can get the attribute value. And within the attribute value, you would want to extract one character at a time. And using the substring function, you can extract one character at a time. So, for example, if we give it the location of the last name tag, then this will return, the first name tag, and this will return the first character from this location, which will be the J for Johnny. So again, coming back to our blind XPath injection criteria, if you found a blind XPath injection, if you run criteria, if you inject the name function with an AND query and make it extract the node name of the root node. Some of these names are pretty confusing. If you try to extract the root node name, then this will return true when obviously you hit the right keyword, which is employees. And if you try to search for crap, then it will return false. So, by comparing the responses, you would know that the root node name is employees. Obviously, in the real world, you would go one character at a time. You will use the substring function, and for each character, you will iterate. And then after you've obtained the value, then you will proceed to the second character. Actually, so much so that you can even read the comments within the XML file. So you can call the comment function and give it the location of the node, and you can start reading the comments within the XML file. And it's funny, we actually found a few XPath injections while we were working on XPath during our pen tests, and some of these comments, we find it quite difficult to put into the reports. You put a screenshot and you want to show them you obtained the comment, which is actually quite niche because you've done the hard work and obtained the comment. It actually has characters you can't put. Anyways, so automating XPath.
Yeah, this is a simple algorithm. You can use it in combination with a blind XPath injection to retrieve the entire XML database that's being processed. So it's quite simple. It's a recursive algorithm. You get the first name, and then you count the attributes, and for each of the attributes you get the value and the name. You then retrieve the comment if it exists, then you count the number of child nodes, and for each of the child nodes you do the same thing, go to step 1. And then last but not least, you get the node's text content. And once all that is done, and you've processed all the nodes, you've got the entire XML database.
Okay, and the good bit is that you don't need to know any of this because Tom has written a tool called XCAT, which does all this for you. Do you want to talk about XCAT?
Yeah, it's written in Python and it's used to exploit blind XPath injection vulnerabilities. You basically give it some parameters and point it at a vulnerable site, and it will retrieve the entire XML database, given enough time. It's open source, so you can come and check it out, contribute some code if you want to. And it uses all the techniques described in the talk. And yeah, it supports XPath 1.0 and 2.0, degrades to XPath 1.0 if 2.0 isn't available.
Yeah, we will show a couple of videos or video demos of XCAT, and we will also be doing an Arsenal presentation on Friday.
On Friday at I think it's about 11 o'clock.
Okay, I don't think he will be sober by then. But whatever time he wakes up, he will be doing a presentation of XCAT. And if you are around, please come and check it out. So let's just show you a demo of XCAT with the techniques we've described so far and how it can retrieve an XML database. Whoa, this is astonishing speed.
So you type in a true keyword. So in this case, the book's iPhone user's guide, and it returns book found. And it's injectable, as we can see.
So if you type in anything or 1 equal to 1, it will still return books.
So we're going to use XCAT to extract the entire database. So it's a post request, and the true keyword is book found. We're going to tell it to use XPath version 1.0 because it supports XPath version 2.0. The quote character is quite important as well. If you get this wrong, it won't work at all. The argument that we're injecting into is book title, and we give it the true keyword. The payload will be appended on the end, and then you point it at the page.
Yeah, I noticed that we couldn't be asked to search for quote character, so we asked users to provide it. We could have easily found out if it's single quote or double quote, but yeah, we'll let users find it.
So it's running through the database now. You can see the request on the bottom.
So as you can see, for each character, because XPath 1.0 do not provide us enough functions like ASCII functions to retrieve the ASCII value and then do a binary search. It's actually a very time-consuming process because for each character you will go through all the alphabets, all the lower cases, upper cases, numbers. So it is quite slow. But the fact is you can pretty much opt in everything. And as you can see here, we have actually got the comment as well, all the books we sell. So if you give it enough time, it will eventually finish, and you will have the entire XML document reconstructed. The XML document might have sensitive information like card numbers, username credentials, so on and so forth. Okay. Moving on. So limitations of XPath. We said it has limited functions, no ASCII functions, no support for regular expressions, not even lowercase. So if you want to find out if it's an uppercase or lowercase, you will have to send two queries, one with comparing small case and one with comparing the uppercase. Not even conditional statement. In fact, we were actually reading into it. There is something called as a Bayes method in XPath by which you can use two substring functions in a very clever way, which will eventually result in a if-then else statement. But what we are trying to say is there is no default way of handling if-then else. There are some hacks, and you can combine the substring and the concat functions in a clever way that it will eventually result in an if-then else criteria. But otherwise, it's not good. So it's slow, but hey, we still have a tool which will do it for you. So we did all this talk, and we thought it was all good. XPath 1.0 is really crap, and there's no way you can make it faster. And we asked around the guys in the team, does anybody know how to make it faster? Said, nah, nobody cares about XPath 1. So we don't really know. And we did a demo run, and we went to the slide, and somebody said, hang on a minute, there's actually a way to make it faster. Okay, good, but it would have been good to know it 2 days before our presentation. So there is actually a way to make it faster. In fact, there are two ways to make it faster. First of all, you can use this clever trick. You can call a substring before. So whatever character you want to test, you can run it on the substring before. So for example, if it happened to be the character B, then the substring before will return from this pattern only A. Okay, and the string length of A in this will return 1. So what you can do is you can eventually find out whereabouts in this particular pattern your string appears, and with the string length you can basically return an index of that string. So this gives you a means to test a character whether it appears in an array of say 256 ASCII character values or not. And this will eventually give you a mechanism to do a binary search. So yeah, essentially, instead of going through 256 iterations, if we assume that the character we want to extract has an ASCII value between 0 and 255, instead of going through all the 256 character set, you can actually run only 8 queries and do the binary search and get the character value in 8 requests. So yeah, that was a bit embarrassing. So XCAT currently do not support this, but Tom will be working overnight, he's promised, and update it to support this. So after we did this, somebody said, oh, hang on a minute, there's another way to do it. Okay, which is you compare character with character, which essentially will compare the ASCII values of 2. We haven't validated it, but from trusted sources, apparently it works. So there are some techniques by which you can still make it faster. We are working on it, and we will update XCAT. Tom will update XCAT. Okay, so does people have any questions on XPATH 1 before we go to XPATH 2.0? Good. I like the audience which don't ask questions. XPATH 2. So XPATH 2 is the new addition within the XPATH query language. It comes with a lot of features. We talked about some of the hacker-friendly functions like ASCII or something like that did not exist in XPATH 1. So XPATH 2.0 is aimed to increase the feature set of XPATH 1.0. So it has a lot more features, and you can do a lot more fun with it. You want to talk about this?
Yeah, it's got a hugely increased feature set. The functions, there are hundreds more functions. You've got regular expressions, you can normalize Unicode, you can convert characters or strings to their code points, and you can reference remote or local XML documents on the file system or over the web. And yeah, all of these can be utilized by XCAT or by an attacker to retrieve the XML document really, really, really fast, as we shall say.
So for example, if you wanted to find out whether a particular value of within an XML is in a regular expression, you can use the matches function and give it a regular expression, and it will tell you whether it is in that pattern or not. So you can speed it up. Similarly, Unicode normalization. You want to talk about it?
Yeah. So if you're searching an XML document that's got Unicode in, you don't want to go through every single Unicode character. So you can use normalized Unicode to break them down into their ASCII components. So you've got this posh-looking E. You can convert it to an E and a...
Posh-looking E, did you say? Okay.
Or an E with an accent, and you convert it to an E and that character. And it speeds up document retrieval, so you don't need to go through the entire Unicode search space, which is quite costly. It'll take a long time.
Okay, so the entire point is that you can use these functions to speed up the document retrieval. Similarly, the most important function probably which we found, or one of these most useful functions, was string to code points. You basically give it a string, and it will return you the ASCII value of each character within the string. So you can use this within substring to return the ASCII value, and then run this the standard binary search algorithm and extract one character at a time. How do you check? So if you found an XPath injection, one of the first things you want to do is find out whether the underlying libraries and the APIs they support XPath 2.0 or not. In fact, so if you run a simple function like lower underscore case, and it returns true for the small case of the capital A, then you know that the lower underscore case function is supported, and hence the underlying API supports XPath 2.0. In fact, before we go any further, we looked into XPath 2.0 and how well it is supported. Do you want to talk about the support of XPath 2.0?
Yeah, it's not that well supported. XPath 1.0 has been around for ages, and it's really quite well supported. Several native languages, such as PHP, have got libraries built into it. XPath 2.0, there's a couple. There's one for .NET and there's one for Java, called Saxon and XML Prime. Yeah, it's not well supported. Hopefully that will change.
Yeah, just to give you some more background about it, I think in PHP we could not figure out a way to use XPath 2.0.
No, there's no libraries.
So it's not. The support is a little bit depending on the libraries. So essentially with XPath 2.0 you can reduce the key space. You can make it go quicker if you do find out an XML which contains Unicode characters and you're not exactly bothered about the actual character, then you can use the Unicode normalization. So essentially the takeaways are the XPath 1.0 do not have much functions, and it is a little bit slower. Having said that, we did figure out in the end to make it faster, but XPath 2.0 has loads, and we did figure out how to make it fast. Um, we don't really have a demo for XPath 2.0. It looks exactly the same. XCAT will do it for you. If you come to the arsenal, we will show you a working demo of XCAT retrieving a document via XPath 2.0. We will just carry on and show you some more niche tricks which we identified. XPath 2.0 has something called as a conditional statements, so you can write if then else. But more importantly, it has something called as an error function, so you can make it to throw runtime errors. Now, why are we so much interested in running runtime errors? That's because I want to talk about a small condition. So, just like in SQL injection, sometimes you come across applications and you try to inject Boolean logic like and1 equal to 1 or and1 equal to 2, and you find out that they return the same page, and there is no way you can inject a Boolean logic. And then you resort to techniques like sleep function, time delays to find out if your queries are actually hitting the database or not. So we will consider a same scenario. The application do not return true and false pages. However, if you do manage to get the syntax wrong, then the application might come back to you and say something went wrong. It might be a 500 error message. It might be a generic string saying the operation didn't go smoothly, or something which gives you an indication when the syntax is wrong. However, when the syntax is right, irrespective of whether you inject and1 equal to 1 or and1 equal to 2, the application returns the same page. And it is actually a very practical scenario. I have come across this quite a lot of time. And what I do find is people often resort to using time-based techniques or out-of-bound techniques to exploit those particular SQL injections. However, I think there is another way of doing it. We are doing it in XPath, and you can the same technique applies in SQL as well. So think of this application which you can select a department and you can send a feedback to the department. So if you select a department, put a message and a subject, then it says email sent. The code which runs on the background is for the department you've selected. It runs an XPath query and it returns a bunch of email addresses for that department, and then it sends out an email to that department. So it will either send out an email or it will not send out an email. Even if the XPath query returns nothing from the backend database, it might send out an email to a predefined or a hard-coded email address. So there is no way you can get a response back whether your XPath returned some data or no data. However, if you messes up the syntax of XPath, then this code will not be executed and your message will not be sent. So the application actually gives you some indication when you get the XPath syntax wrong. So now what we can do is we can inject an if query, and within the if query we can inject a payload which will be a Boolean payload returning true and false, and we can set it so that when our payload is true, it will throw a runtime error. However, if the payload is false, it will not throw a runtime error. So this is what we call as a true and error condition, which is similar to true and false condition. And now our error condition can be either true condition or a false condition. So we've basically converted this application into a simple true and false by making it throw a runtime error. So runtime error is your criteria now. So this is how when you get the syntax wrong, it might look like. It does not have to be a 500 error message. It can be a generic string saying something went wrong, just something which will differentiate between a non-syntax error and a syntax error. Okay, XPath 2.0 supports something called as a doc function. And this is where things get really interesting. What you can do with a doc function, we'll talk about this.
You can do cross-file joins with doc functions. You can reference remote files locally. So if you were to do an XPath query, the first one, so you're calling, you're going to load the cross-domain file from twitter.com, and it's going to return the name of the first node. And then you can use that in a query. So you can say if it's equal to something, or you can blind extract it, and you can load files from the file system. So in this case, it's loading a config file, and it's going to get the name. It's going to text value of the first root node. So if you do find an XPath injection vulnerability, you can read local files, or you can reference and term documents.
So yeah, if you find XPath injection in XPath 2.0, then you can call this doc function to read any arbitrary XML file on the local file system, or even on a remote file system to which this vulnerable web server has access to. So you can make it connect to a remote HTTP 192.168 or an IP on the DMZ, obtain a sensitive file via HTTP client or SMB client within the doc function, and start reading that. Start applying all those node count, the functions which we went through on the doc function, and start reading local or remote XML files. So again, you don't have to do this. Tom has done this for you.
Here's an example. So I'm going to make a new text document, a new XML document called secret.xml. So I'm looking at some arbitrary data in here. So it's a secret root node and a top secret node. Then hopefully we're going to use XCAT to extract that. Okay, so this is our Thunderbird application again. We're going to use the get current working directory thing, which will extract the current working directory of the XML file that's being parsed. So if we change...
I think we didn't talk about the get CWD. Basically, there is a function in XPATH 2.0 with which you can retrieve the current path. So that will directly give you, an idea whether the underlying operating system on which the queries are running, is it a Windows box or is it a Linux box, which is quite useful. And obviously, if you want to brute force certain file names, there's no way you can figure out what the file names are. You will either have to know it or make an intelligent guess. Like if the backend system is running a Tomcat server, there will be a Tomcat users.xml, some generic XML files if you want to read. So knowing the file location is very handy.
You can replace that with the file shell command, and then you can just paste in the URI, change it to secret.xml, and it will. There you are. It returns the XML document we've just done. And of course, you can change that to Tomcat user.xml or any parsable XML file.
Yeah, it's important to note here that it does not have to be it has to be a parsable XML file. It does not need to have the extension .xml as long as it is a parsable XML file. I mean, some software might store a configuration file and not call it with a .xml extension, call it with a .config extension. But if it is an XML file, a well-formatted XML file.
Would HTML be retrievable in that way?
Ooh, that's a good question.
Simple XML, yes. I don't know how it. Yeah, it should do.
I don't know how strictly it will follow the XML guidelines. It's one for us to check, really. It's a good question. It's a good question. Okay, the answer is we don't know. We'll find out. So essentially, you can read any arbitrary file, local or remote, which this vulnerable website or vulnerable app server has access to. Okay, more fun with doc function. Now what you can do is, instead of using it to read arbitrary XML, you can actually speed up the document retrieval. So you can make the doc function connect to your website, and think of it like an out-of-bound HTTP extraction when you do a SQL injection. So you use the doc function as an HTTP client and make it connect to an attacker-controlled website. And the payload which it will issue in the GET request will contain strings coming from a backend XML document. I think this will get clear if I show you an example. So within the doc function, if you make it connect to your hacker.com, and as an argument to the concat functions are XPath expressions, which will be evaluated. So we will try to read the current XML document and try to read the username field and similarly the password field. And whatever is returned, that will then be appended to the URL. And the end result is that your vulnerable website will make a request to hacker.com with the username is equal to jbravo and the password is equal to the password element. So if you control the access logs of your hacker.com, you will see these queries appearing on your website. And now you have basically speeded up in one request. Rather than getting one character, you have actually the entire value. I mean, you can write a little bit more complex XPath, and you can probably get more than one node name, node values. You can do a lot of stuff with that. So again, I don't know if we have do we have a demo of doc function?
We don't.
Okay, so this is already implemented in XCAT. Obviously, if you are exploiting a website on the internet, then you will have to run the XCAT on a routable IP address. So it has to be a public IP address. But you can give it a -- connect back switch, and it will listen an HTTP server, and it will make the vulnerable website issue HTTP requests to your XCAT server, and you can retrieve the document via HTTP channels. So this is just a picture showing how it works. You will send a payload, and the web server will connect back to your attacker site, and on your access logs or whatever listener you have, you will start seeing the XML data. There are some limits, like the limit of the GET request, but it's an attacker-controlled web server, so you can tweak your HTTP server and increase the size it can receive via the GET request. So the only big limitation of the doc function and making it connect over HTTP is obviously the egress filtering. The vulnerable web server needs to connect to the attacker-controlled web server, and if there is an outbound, if there is a firewall rule which stops the outbound port 80, then this attack will not work because it will not be able to connect back to the hacker-controlled website. So what you can do is you can use DNS channels. I mean, just simple to do, just as you would do in SQL. So instead of making it connect to your HTTP server, you make it resolve crafted names. And that names comes from XPath expressions. So in this case, it will try to resolve jbravo dot whatever the password is, test123.hacker.com. So if you listen on your hacker.com's authoritative name server, then you will see all these name queries coming onto your server, and then you will be able to reconstruct the entire XML document. We don't have in the XCAT, we currently don't support DNS queries, but we support the HTTP channels. The only limitation of DNS, and I mean, I actually think it's quite practical. It's as practical as doing an out-of-bound SQL injection. And in the wild, doing pen testing, I have found a lot of websites in which the only method of exploitation was the out-of-bound DNS channels. And almost in only a few scenarios it has failed. So I actually don't see it failing. It might be a very popular technique going forward. There are certain limitations, like whatever characters you are trying to resolve must adhere to DNS specifications. So if the name had some special characters or punctuation marks, it will not adhere to DNS specifications, and the name will not be resolved. So you can use, again, XPath 2.0 provides such a rich library that you can use functions like hex encode or encode for URI, and encode those names. And when you receive the name queries on your attacker-controlled website, you can decode them back in whatever form you encoded, and then you can get the values. DNS queries might get lost in transit, but you can run multiple queries. That's not a big deal. We'll talk about XQuery. Do you have anything to add to that?
No.
Any questions at this stage before we go on to XQuery? Okay, we're doing well for time. It's a little bit over. So XQuery is like a superset of XPath. XPath was a query language. You only use it to query within an XML document or XML database, and it returns certain node set. XPath is a I got it wrong. XQuery. Okay. XQuery is a superset of XPath. It is a query language as well as a programming language. So from the programming language side, it has things like for loops, let. You can declare a variable. You can write a where clause. And you can do some sort of a funky programming within XQuery, which you cannot do in XPath. And XQuery is also a query language. So XQuery is a superset of XPath. XPath is only a query language, and that XPath's query language is as it is implemented in XQuery. So XQuery's query language feature is essentially XPath. Did I put it right?
Yeah, no,
okay.
Right. You can do stuff like define functions. You can create your own libraries. There's a huge, rich feature set.
You can create a function. You can define a variable and use that variable. So within XQuery, you can have an XQuery injection in the same way as you have an XPath injection. Except that obviously now we can use the rich features of XQuery to do a lot more stuff with it. In terms of the XQuery injection, almost always, or in most of the scenarios, the injection will occur when the XQuery is using the query language option. So typically XQuery will use XPath expressions to issue queries. And typically, the injection will be within the XPath's expression of the XQuery. So every time you have an XQuery injection, you can use all the features of XPath injection. It's slightly confusing, and if you are really interested in the topic, I would suggest you read the white paper which we've written with this. It explains it quite well, or at least we hope it explains quite well. So think of it as, here's a simple example. You're searching for all the blocks of user admin. It uses an XQuery expression. It uses an XQuery to query an XML database and returns the first name and the last the first title and the blog post from the backend XML database. And this is how the code will look like. So this is where your input goes. It's basically searching for author name, whatever is supplied from the input, and whatever is supplied is from the backend XML. It is returning the title and the content. Because XQuery is such a rich language and it allows for a lot more things, what you can do is you can write one massive XQuery or one massive XQuery dumper script, which we have written. And what this will do is this will go through the entire XML document, and for each node name, node value, attribute name, attribute value, and blah blah blah. For each of these values, it will make a recursive HTTP lookup. And basically, by sending this one crafted URL, you can have that vulnerable website connecting recursively to your website, and you can have the entire XML document reconstructed by sending this one crafted URL.
There is one limitation of that though. It'll only go one level deep. So you can't write a fully recursive function. So you can copy and paste the for, C, and child bit over and over again. But so what I'm trying to say is it'll get one root node, then it'll get the child of that, but it won't go any deeper than that.
Okay, our XQuery dumper script does not do it, but we are not saying it's a limitation of XQuery. Somebody more clever might be able to write a better. This is the XQuery dumper script version 1.0. It's work in progress, and for now it only goes one level deep. But hopefully in future it will go more recursively. Thanks for pointing that out. So as you can see, it's going to make recursive queries on this. This is how the URL will look like. So we call this one query to get them all. You find an XQuery injection, and our dumper script will make recursive requests to hacker.com and start dumping out the entire XML database. So we have a small demo. I'll show you this.
So lucky us, this is injectable. We can just encode our payload, which is the dumper script.
So this is us just using this is just Tom being geeky. He's using the Python interface to URL encode that string rather than do it in a non-geeky fashion. Essentially, this is just URL encoding the entire dumper script. So you just whack it in the URL. I don't know if you can see it.
And there you go. That's the logs being tailed. You can see that each of the attributes are different request arguments there. Path. Yeah, I don't. Sorry.
Just put it on the last one and pause it. You probably can't try again. Yeah. Okay. The video probably don't do justice to this demo, but essentially we've sent one URL, and that one URL has made like 10 or 12 recursive requests onto our HTTP server, and you can see that some of these fields which we have received on our HTTP server were not directly displayed onto the website, and they were like the hidden fields within the XML which nobody was supposed to read. It's also worth pointing out that in this demo we are reading the current XML document, but again, because it's XPATH, it's XQuery and it supports XPATH, we can call the doc function within our dumper script and start reading arbitrary XML files, not just the current XML document, but anything either locally or remotely. Okay, we'll talk about this.
Yeah, when we were testing this, we tried two parsers. The Saxon one is too clever for us, and it works out that query actually doesn't do anything. So it ignores it. It uses lazy evaluation because the variable that we're using isn't actually used in the query. So, but we tried a different one called XML prime, and it worked like a treat, and it dumped the entire thing. Yeah. Okay,
so what we're saying is it may work or it may not work depending on the parser which is being used in the backend queries. If it works, all well and good. If it does not work, then all the XPath features are supported in XQuery, and you can use all the techniques which we've talked so far. You can use the blind injection, you can use the error-based injection, or you can use the out-of-band channels to extract any arbitrary XML document. Now the last topic, hopefully, 10 minutes to go still. Okay. The last topic of this talk is Exist database. Can we talk about Exist database?
Yeah, Exist database is it's what MySQL is to XPath. So it's a process that runs on your web server or database server, and you store your XML files there, and then the clients connect to it via HTTP. So this is an example query string, and they issue XPath or XQuery queries via the query parameter.
Underscore query parameter.
Underscore query parameter. So this means we can use it within XPath using the dot function because it's only a GET request, and it will return the result of the query as a node, as a readable parsable XML node set.
Okay,
which
so,
we can
so
manipulate.
you will basically dump all your, so if you have a collection of XML files, you will dump all your XML files into this exist database, and then you will use this connection string of exist database, which is localhost 8080 /exist/res/db database, and make it point to a particular XML file within that exist database, and run a particular XPath query on that database, with supplied under the underscore query parameter name. And you can use the doc function within the XPath to make this to run this query. So if we go back to our previous example in which we were searching for the username admin within a flat XML file, if that file does not happen to be a flat XML file, but it happens to be an exist database's XML file, then our application will basically first connect to the exist database, and on the exist database, it will run the query which will contain our input. So what we are saying is if your XPath expression, which is run on the exist database, happens to be vulnerable to injection, then you can do XPath injection. But those queries will actually be run now on the exist database rather than on the flat file or on the host, which will host that flat file. So what you can do, I mean, just to do a little recap of what we can do, because this is how it will work in the wild, and this is where it gets a little complicated. So if you found that the admin page was if you found that the username parameter was vulnerable, then you can basically inject a doc function and make it read arbitrary XML files and start sending out data to our hacker.com via the HTTP channels, as we talked about earlier.
Because the exist database is running as a different process than the web server, it might have different permissions. So in this example, it's reading the config file that the web server wouldn't be able to access.
This is the master config file of the exist database and not the current XML document.
And if you're lucky, they might run it as root or something other silly.
Okay, so exist database basically adds a few new modules to XQuery, and it's like an extension of XQuery. And this is not really an extension of the XQuery library, but this is specific to exist database. So it has some modules like HTTP client, by which you can make it connect to a remote HTTP server. It has an email module by which you can send out emails. So a send mail function essentially, which lets you send out files. An LDAP client, and a client which will let you connect to a remote Oracle database and run PL/SQL stored procedures, so on and so forth. But more importantly, all these clients are disabled by default. The only client enabled by default is the HTTP client. So you can have a little bit fun with this HTTP client. Obviously, so this is how it will look like. You can use the HTTP client modules, post function, make it connect to attacker's website, and make it dump the entire XML in just one request. And this can be either the current XML document or any document on the file system. We'll show you a demo, but this is how it will look like when you use the HTTP client function. HTTP client modules post function. You will essentially specify the website you want the vulnerable website to connect to, and the root node name or the doc function, and the serialized XML will be posted to that website. If you run a listener, this is how it will look like. In one query, you will get the entire XML. So we'll quickly show you a demo of this.
That's the last one. So this is the exist admin shell where you can run commands and see the output.
So this is like the SQL Plus interface which you have in Oracle, or the MySQL command line interface which you will have. You run an XPath expression or an XQuery, and you will see the output on the screen. So this is just us using the native client and the native functionality as it is, without any hacks. And we are trying to make it connect to hacker.com and post the entire root node. And when we do it, then you will find that on the hacker control website, in one request, it has dumped out the entire XML. This is using the native client feature. Obviously, the next thing is you can use it as a hack, and you can post it via the URL. So all you do is
So this is the query that's being executed. If we break out of this, let me just create a new variable, which is going to be ignored.
Your typing speeds have improved.
Yeah.
So we are making it connect to hacker.com and giving it a serialized root node name location.
And then we just create another dummy variable to deal with the additional.
This is us just trying to work out the syntax and trying to make sure that whatever we are injecting do not break the syntax of the query. So if we just copy what we've injected via the URL bar, you will obviously have to URL encode whatever you send. Then you will see that in one request via our XML on our HTTP server, we can retrieve the entire XML document. Okay, I think that's pretty much it for the attacks. We'll just quickly talk about protection and mitigation. I know most people over here don't really bother. So, I mean, it does not really take a genius to figure out how to save yourself from it. Sanitized input is the first rule of thumb. Try a whitelisting, avoid blacklisting. A lot of vendors down there will give you a lecture on blacklisting, why it is bad. Use parameterized query, separate data from the code, so that even when you don't control the input, your code is not evaluated, it is interpreted as data. And the doc function, we'll talk about the availability of doc function.
Yeah, if some libraries, the doc function is allowed by default. Others, you need to explicitly allow it. In either case, you should not use it unless you need it. And if you do, you should always sanitize as your input. It's quite easy. Any library will have the document. The docs will tell you how to disable it.
That's it. Thank you very much for your time. And if you have the questions, don't ask them. Go on.
I have two questions.
Yeah.
Are there ways to write into the XML or into the file system?
That's a good question. So we started to look into this and we didn't. So the question is it possible to update the XML document or write to the current XML document or some other XML document? That's the question?
Or in the file system?
Or in the file system. There is in XPATH 2.0 or...
There's a working draft. There's a working draft for something called the XQuery update, which is an extension to XQuery, which allows you to insert nodes or update certain fields, just like the SQL update statement, but it's still a working draft and it is not well supported. But yeah, when that's finished, then yes, you should be able to.
Yeah, and you should be able to do some clever stuff with it. We kind of looked into it, but because it's not very well supported, we were not able to get a working copy of it. But if you do manage to get it to work, I can see that there can be a few attack vectors like reading an XML entity or writing an XML entity and then calling it back and reading file systems objects. Second question.
Second question is about the exit of the database. By default, it only has enabled the client, the HTTP client. Can you run a command to enable the other?
You have to.
No. So the question is, on the Access database, by default, only the HTTP client is enabled. If you do find an XQuery injection, can you not run some commands and enable it and then use them? That's the question.
You can, but you have to be a super user to do that, and you need to use the admin console to do that. But it's enabled or disabled explicitly in the config file.
I actually beg to differ. I think you can't do it because you have to restart the Access database.
Oh yeah, and you have to restart it.
No, I'm pretty sure you can't do that because it's in a configuration file. You will have to enable it and then you have to restart the Access database. So unless you find some uber awesome XQuery injection which will let you restart it as well, then maybe you can. But to the best of my knowledge, you can't. Any more questions, anyone? Yes, sorry.
Does querying the database cause a lot of load on the server? Or?
The question was, does querying the database cause a lot of load on the server? A little bit. It depends on the size of the data set. But Access database is quite fast. It's built to handle a lot of XML data. And some sites, big sites, use it. I think Google uses it.
I think just a standard Boolean logic expression which you've injected, it should not really cause anything. But if you're using things like doc function to make it load a remote XML file, then obviously the bulk of the time is going to go into the network connection and retrieving and parsing the XML file. But if you inject the standard Boolean logic and use the standard blind injection techniques, then it should not really cause any CPU usage.
Docs
Yeah, if you run the doc statement in a loop, then it might cause a little bit overhead.
Okay.
But I don't think it will break anything.
No.
Yeah.
Any more questions?
Cool.
That's it
Well,
then.
guys, you survived the talk. It's time to reward yourself with a beer.
If you're interested.